Welcome to my CompTIA Security Plus Guide to Network Security Fundamentals, 5th edition. Here we're looking at Chapter 11, the Access Control Fundamentals. So in this chapter we're looking at the access controls, the lists of the 4 access control models, how to implement them, and explain the different types of authentication services. So first of all, we have to understand what is an access control. Access control in its basic form either will grant or deny approval to specific resources. Now we have typically 3 types: physical, technical, sometimes called logical, and administrative. Those are the 3 major types. Physical access controls will be things like fences, hardware locks, man traps, things like that. Technical or logical controls will consist of technology restrictions that limit users on a device from accessing specific types of data. There are 4 standard access control models, which we will discuss shortly. Before we get into too much in depth, we need to understand some basic terminology. Access control terminology like identification, authorization, authentication. Identification is basically presenting credentials. Authentication is verifying or checking the credentials, essentially verifying that you are you, or who you claim to be. Authorization is granting permissions to take. So the normal example that I give, you go to an ATM, you put your PIN number and debit card in. By you putting the debit card in, that's identification. Once you put the debit card in and you type in your PIN, the ATM has authenticated you as you being that account holder, and then the next portion is allowing you to do whatever you're authorized to do. So you could be authorized to withdraw money, you could be authorized to deposit money, or you could have a special card that only allows you to deposit money, and so after you have been authenticated, you may only be able to deposit money. Again, the authorization is going to be dependent on what control is in place and what permissions you have for that card. Here's another set of examples for authorization, authentication, identification, and a new one, access, and that's going to be the rights or permissions given to specific resources. Additionally, we have to talk about objects, subjects, and operation. Object is a specific resource. Subject is typically a user or a process functioning on behalf of a user. Operation is the action taken by the subject over an object. Subjects are typically people, objects are resources, though sometimes people can be objects. Here are the examples. Alright, so here we have an example of a subject, and we have a file, salary.xlsx. We identification by providing a username. We authenticate by the username and password, verifying that they are correct. Authorization should be allowing us to access that document, and then the access would actually be the opening of that document. Access control models. There's a standard model that provides a predefined framework. Using the appropriate model to configure the necessary levels of control. The 4 major models are discretionary access control, mandatory access control, role-based access control, and rule-based access control. Those are the 4 big access control models, and we're going to look at each one of them in depth. Alright, so let's start with DAC. This is a least restrictive model. Every object has an owner. Owners have total control over their objects. Owners can give permissions to other subjects over their object, and it's used in operating systems like Windows and other versions of Linux and Unix. Here is a general type of DAC. You can actually provide permissions to additional users or groups. DAC has several weaknesses. It does rely on decisions by the end user to set proper security levels. Incorrect permissions. For example, you could accidentally deny or grant permissions. Subject permissions will be inherent by any of the programs the subjects execute, so that could be a problem. Malware could affect file types. Mandatory access control, MAC, is the most restrictive access control model, typically found in the military. There are two major elements. There's a label and a level. Within the labels, every entity is an object and is assigned a classification label that represents the relative importance of the file. Subjects are assigned a privilege label, such as a clearance. The levels are a hierarchy based on the label is used. Top secret has a higher level than secret, which has a higher level than confidential, for example. MAC grants permissions by matching object labels with subject labels. These labels will indicate the levels of privilege. To determine if files may be opened, the object and the subject labels are compared. The subject must have equal or greater level to the object to be granted access. The two major implementations of MAC are the lattice model and the Bell-LaPadula model. So again, what ends up happening is you'll have the object and your subject labels. You'll compare the two. They must be at least equal or better. So you, as the subject, have to be either the same label or above in order to access that object. For example, if the object is secret, and you, the user, have top secret. Top secret has both confidential, secret, and top secret, and the object, while it's classified as secret, it can be opened by either secret or top secret. The lattice model, basically subjects and objects are assigned a rung on the lattice. Multiple lattices can be placed beside each other, where the Bell-LaPadula model is similar to the lattice model, but subjects may not create a new object or perform specific functions on lower level objects. This BLP model is actually very heavily tested on in additional security courses. I just thought that was kind of interesting. Microsoft Windows does use a MAC implementation. It's called the Mandatory Integrated Control, and it's used by things like the Security Identifier, or the SID, and that is issued to a user, group, or session to uniquely identify them. Each time a user logs in, their SID is retrieved from a database for that user. The SID is essentially how the user interacts with the user itself, because the system doesn't know the user's name, it only knows its SID. And the SID is used to identify and to interact with Windows. We also have what's called the User Access Control, the UAC, and this is a Windows feature that controls user access to resources implemented in Windows Vista and above. Here's an example of a UAC prompt. Moving on, we have our role-based access control and our rule-based access control, RBAC and, RBAC. Role-based is also called non-discretionary access control, and essentially access permissions are based on the user's job function, their role or job function. RBAC assigns permissions to particular roles in an organization. You're an accountant. Accountants should have these permissions. You're an executive or a manager. They should have these permissions. You're a worker in the engineering group. They have those permissions. So the users are assigned to those roles. We also have what's called a rule-based access control, also known as RBAC, and these are dynamically assigned roles to subjects based on a set of rules defined by a custodian. A custodian is typically the person in charge of or overseeing data. Each resource object contains an access property based on the rules. When users attempt to access the system, these, The system will check the object's rules to determine the access permission. Often used for managing users' access to multiple systems, businesses may change and may trigger applications based off of these rules that are specifying access changes. Business changes may trigger application of the rules specifying access changes. So these rules may change. Restrictions and descriptions for MAC, DAC, RBAC, and RBAC. Understanding the difference between role-based and rule-based are actually really important, because more often they're just called RBAC, and you have to understand it's either role or rule, and they are slightly different. Role-based is more considered more real-world. Rule-based is used by managing users' access. MAC is again most restrictive. DAC is again least restrictive. So now that we have a basic fundamental understanding of them, we can talk about best practices for them. Establish best practices for limiting access to resources. Things such as least privilege is really important. A person should only have the minimum required privilege in order to do their job. Also things like separation of duties. Making sure that, for example, cutting a check. The person that writes the check is not the person that signs the check. That's not the person that can deposit the check. That's not the person that can record the check. There should be separation of those duties. One person writes it, one person signs it, one person deposits it, a different person records it. That way, there's checks and balances. Also, the 4 individuals may rotate their jobs. That way, not a single person is doing the same job and is able to cover up anything. There should be an implicit deny. Basically, you'll have an access list, and at the very end of that access list, if nothing is met, deny it. Also, there should be mandatory vacations, just so that you can see the processes occur when one of the key individuals aren't there. Basically, it's a way to make sure that nothing is being covered up. Okay, again, separation of duties. Fraud can result if one person is trusted too much. Job rotation we've already discussed. Employees can rotate within their department so that they can not so much cross-train, but again, the nice thing is it limits the amount of time individuals are in a position, so they are less likely to be able to manipulate any of the security controls. This will also help expose potential avenues for fraud. This also will help reduce employee burnout. We've already talked about least privileges. Again, users only have the minimum amount of privileges able to do their job. Okay, again, we've already talked about things like legacy application in previous chapters. Common administrative tasks. That will be in some organizations, basic systems, having to be able to manage them. Same thing with software installation and upgrades. They're not always centrally deployed, and that means you may require higher level privileges, so users may have to install them, or specific users with the appropriate permission may be able to install them. And those are all concerns with that least privilege concept. However, long term, that is actually a better level of protection. What I mean by that is you can have really good controls, but yeah, I understand having to have an IT support person with elevated privileges to install updates is time consuming, but it does beat having regular users granted access so that they can do it. Because if a regular user can do it, they may install things that they're not supposed to. So again, there's pros and cons for both, but the implicit deny, again, if the conditions aren't met, reject it. Mandatory vacations, again, that helps limit fraud, and it allows for an audit of employees' activities during, they're usually scheduled during their vacation for sensitive positions. That way, an audit can be done, and everything can be reviewed and verified and checked just to make sure. Technology is used to implement the controls. Logical controls could be things like an access control list, group policies. Group policies, both domain or local or site, or even just account restrictions. And I got ahead of myself again. An access control list is a set of permissions for an object. Basically, it tells you what you can and can't do. When you go to request access to an object, the object will verify with its ACL that you, the subject, have the appropriate permissions to do what you're wanting to do. Here's an example of an access control list. What you're allowed, read, write, execute, or read and write, or read. And again, this is an example of Unix file permissions. Each entry in the ACL is called an ACE, an access control entry. Within that ACE structure, there's typically an identifier for the user and groups to SID, and there's an access mask that specifies the access rights controlled by that ACE. Flags that indicate types of ACE, and you set the flags that determine whether the object can inherit permissions or not. So if you have an object in a folder, that folder may have certain permissions, and the object may have certain permissions. Well, because the object's in the folder, the object may inherit the permissions of the folder if the flag is set to inherit those permissions. Again, group policies, normally found in Microsoft Windows Server using something called Active Directory. We have things called group policy objects. We also have what's called a local group policy. And the local group policy is on every Windows machine. The group policy for the domain or for the Windows Server actually will affect all machines that are on that domain. There's more details than that because you can set a structure to that. But normally you can centralize policies to be pushed out via the server. Account restrictions can be things like limit the time of day that users can log in, maybe do time blocks for permitted access, maybe even limit what systems you can log into. Account restrictions, allowed or blocked. You can also have account expiration, basically letting you know when accounts expire. Dormant accounts not accessed for a lengthy period of time could go expired, or even orphan accounts that remain active after the employee has left the organization. They should be expired or disabled. Recommendations for dealing with the orphaned or dormant accounts. You have an administrative control policy or procedure, and then you have a technical control that actually will verify the accounts are either expired or disabled. And again, normally that's done through both the admin and logical control. So how do you verify that this is happening? Basically, you monitor logs for dormant accounts logging in. Orphan accounts remain a problem in today's organization. So typically it's easy to set a user's account to expire, maybe every year. But again, that requires more administrative overhead, and so that's not done very frequently. I've seen more a user checklist for termination, and basically you go through the checklist to verify every step is complete. Authentication, we've already said, providing or verifying that you are you. Authentication services provided on a network. Normally we could have a dedicated authentication server. So the server will perform things like authorization, authentication, and accounting, called AAA. And AAA has two common types, things like Radius or TACACS. There's also things like Kerberos. Kerberos is the basis for Windows Server authentication. Most things will use things like LDAP or the Security Assertion and Markup language, SAML. Though SAML is not really a authentication or server type, where Radius, TACACS, Kerberos, well, Kerberos is more of the function of it. Radius and TACACS are the big two, and LDAP. Active Directory is based off of LDAP. LDAP is not program specific, so it can run in Unix, Linux, or a Windows environment. Radius is what actually will allow us to send the AAA authentication or authorization between a hardware device and a server for authentication. Same thing with TACACS. Radius is Radius because it stands for Remote Authentication Dial-in User Services. It is a very heavily industry standard. Radius clients could be things like a switch or wireless access point. More often than not, when you have to log into the wireless using your username and password that you use to log into the computer, that's being sent through a Radius server. You have a laptop, you connect to the wireless, you provide your username and password, the wireless access point sends it to a Radius server, and they check with an account server to verify your Radius, to verify that your username and password are correct. That Radius server is the intermediary between the access point and the account server that verifies your username and password. Radius user profiles are stored in a centralized database. If we're talking Windows, we're talking normally Active Directory. Kerberos is an authentication system developed by MIT. It uses encryption and authentication for security. It's more often used in educational and government settings. A lot of the Windows Server environments are based off of Kerberos, so Kerberos is in more than just education and government. It works like using a driver's license to cash a check. The Kerberos has a ticket characteristic. It's hard to copy. It's hard to forge. It does contain information linking the ticket to a user. Users present the ticket to access resources, and the tickets do expire. TACACS is Cisco proprietary, similar to Radius, but again it's proprietary. Current version is TACACS Plus. There are things that are slightly different, where like communication for Radius is unencrypted, TACACS is encrypted. TACACS is connection oriented, so it does use TCP. TACACS also interacts with Kerberos and can authenticate network devices, where Radius doesn't. But Radius is the general standard that is used. LDAP is a directory service protocol, and it's used to contain information about users and devices. It does keep track of network resources, and the privilege is for the subjects using to access those objects. It will either grant or deny access based on that information. It does use a standard for directory services, which is called X500. X500 standard defines the protocol for application. LDAP is a simpler subset of DAP. It is designed to run over TCP. LDAP traffic is transmitted sadly in clear text, so that's why we have things like Secure DAP, also called LDAP-S or LDAP over SSL. LDAP is a lightweight directory access protocol, and that's what we use to access our directory services. They are subject to injection attacks, even though newer versions aren't as aren't as vulnerable to these types of attacks. Moving on, we have what's called our security assessment, or a security assertion markup language, SAML, and this is very similar to XML, but it's more secured. It's used mainly for e-commerce or business to business or business to customer transactions. Basically, it provides the framework between the service provider and the user, and it will have an identity provider so that you can verify the code is secured in transmission. And that is this chapter in a nutshell. Again, this was basic understanding how to implement basic controls. If you have any questions, please reach out. Thank you.